So we would like to solve an equation of second degree. So a second degree means to have the term, the coefficient here is will not be zero. Okay. So let's show how we can proceed. At the same time, we give the proof. Okay. So the proof for or the method exactly starts from completing the square. So if I complete the square, so I will have I factor e as the constant. I put it as common factor. So I will have b over e x plus c. Let's stop here. Equal 0. Okay. Then I work on the expression inside. Remember, we can do we show our beginning of square, so it's b to a. Okay, so that I get exactly this term. Then so I have like x square plus 2 times alpha x plus alpha square, so I will put b over 2a square minus b over 2a square. Okay, plus c equal 0. And yeah, and then we have the beginning. So we set a square here. So we have a times x plus b over 2a square minus, now if I develop, or let's keep it one line more, we can write more, x plus c equals 0. So if I develop, so I will have a times x plus b over 2a. So I'm sure I have already term that is power 2. If I develop, I will have minus a times b square over 4a square plus c equals 0. Now let's move the constant to one side. And yes, and then so we will have x plus b over 2a square equal a times b square. So I can reduce b square. Let's b square go slowly, step by step, minus c, which I can write e um, e times or just wait, continue. We will simplify by a, so we will have x plus b over 2a square. We will have b square over 4a square minus c over a, which reducing to the same denominator, I miss here for c for a. So I will have b square minus 4a c over 4a square. So let's set these quantities, set delta, the quantity b square minus 4ac. Okay, so we have exactly here 4 delta over 4a square. Okay, so if now I can discuss all the situation and have the rule for the general rule. If I have delta positive, okay, then the right hand side is positive, so I can I will have then with so this okay, we can write it as square root of delta over 2a square. So the general solutions will be x plus b over 2a equal plus or minus square root of delta over 2a. And we have all the possible solutions, okay, which we can write also x equal b plus or minus square root of delta over we have the same denominator. Now, if my delta is negative, delta, so here this writing is correct when we have a delta positive, otherwise we can write it, okay? Okay. So when my delta is negative, it's clear that I have no solution. Okay, no solution. We cannot have a square quantity that is positive or equal to 0 equal to a number quantity that is strictly negative. So no solution. Now, if delta is 0, then we have a unique solution. X equal, because we have 0 here. So the only solution, like you can deduce it from here, it's minus b. So I missed here minus b. I moved minus b over 2a, which is a double root. Okay, double root. So finally, this quantity is important, is the discriminant of the equation. And we have these three possibilities. We have uh, a complete control on the situation for second order equation. So let's look then, let's illustrate there's three situations with um, three equations. Okay, 2x plus 1 equals 0. Here I identify my a. Okay, a is 1, b is 2, and c is 1. Okay, so my delta, instead of going through the proof using the completion of the square, we can just introduce the discriminant b square minus 4ac. So it will be 2 square minus 4 times 1 times 1. I see it's 0. Then I have one root, x equal minus b over 2a equals, so minus 2 over 2 times 1, which is minus 1. Okay, so my solution, the unique solution is x equal minus 1, minus 1. Okay, at the same time, yes, you can write also factor your expression. Sometimes you need to do this work just for factoring our expression. So it's x minus minus 1, which is plus 1 squared. Okay. Yes. I didn't. So here, for example, your expression here, let's add it here, bx plus c, you can write it as a times x minus your x0, or plus b over 2a squared. Okay, so you have this factorization. For for this case, when we have two roots, you will have your expression ax2 plus bx plus c equal a times x minus x1 times x minus x2. So the factor a, you have it outside, okay? And this one is for this situation. So it's important to use this delta expression either to solve an equation or also to solve an equation in purpose to have the roots and then factor your expression. Okay. Okay. The second example, let's do another example, second one. For example, what we have, if we have x2 plus 2x plus 2 equals 0, delta b square minus 4ac, my b is 2 minus 4 times 1 times 2, so it's 4 minus 8, which is minus 4 negative, so no solution. Okay, and even your expression cannot be factored. You cannot find the factorization. And a third example, let's do this one. Okay, the third example is x2, 3x2 minus 5x minus 1 equals 0. Delta b square minus 4ac, so it's minus 5 square, 4 times 3 times 1, minus 1. Okay, this is my c plus c. So this gives me, so 25 plus 12, which is yes, 37. Yes, it's 37. 37 is something positive. So I have two roots, x1 minus b minus square root of delta over 2 times a. So minus b will give me 5 minus square root of 37 over 2 times a, 2 times 3, which is 6. And x2 will be minus b minus square root of delta plus, over 2a. So it will be 5 plus square root of 37 over 6. Then the factorization, okay, your expression also, you can write it as we said 3x2 minus 5x minus 1. So those are the solutions, those values, but you have also factorization if you need it. It's 3 times x minus x1 and x minus x2. It comes from here. You write this expression as square, so you have difference of 2 squares and you get the factorization with the factor a. Okay, so here it is. Yes, this is what